Okay, so what would you do for the number of elements in A intersection B? What's that equal? Well, you might intuitively say that, well, if we add everything in A to everything in B, we've counted the intersection twice. If we just count it once, we get the number in A union B. So maybe we should take the number in A plus the number in B and subtract it from the number in the union. And if you can think that clearly, and some of you I believe can, not everybody, because it's requires quite a bit of working memory and some experience in thinking about things like this, but some of you can probably do that. The safer way to do it, and that's not to say you shouldn't understand it the way I just said it. If possible, you should, but the secure way to get that number is just to write down, okay, we know this. Number in A union B is number in A plus a number in B minus a number in A intersection B. Okay? So, we could add the number in A intersection B to both sides. Number in A union B plus the number in A intersection B is the number in A plus the number in B minus the number in A intersection B plus the number in A intersection B. So this showing up as a negative here, if we add it to both sides, we're going to have the negative of that number and we're going to add it to that number, and that's just going to give us 0 over here. And of course then we're going to have to, anything we add to this side, we have to add to this side if we want them to stay equal, with the two sides to stay equal. So we get n of A union B plus n of A intersection B equals n of A plus n of B. And then what do? Well, let's just subtract A union B from both sides, because if we do, A union B minus A union B is 0. We'll just be left with number in A intersection B. So we'll do this, number in A union B plus a number in A intersection B minus a number in A union B equals a number in A plus a number in B minus the number in A union B. Okay, so this and this are equal and opposite, they subtract, and now we're just left with the number in A intersection B, and we can just write down our right hand side once more, and we have it. Now, I'm not going to do examples of every possible rearrangement, but what if we wanted to get the number in A? What if we were asked to express the number of elements in set A, or the cardinality of set A, in terms of the cardinalities of A union B, B, and A intersection B? Now, we could go back to the Venn diagram and figure it out. That's one way to do it. We don't necessarily have to use the simple algebra that we used here. It might not look all that simple to you, depends on how secure you are with your algebra, but we don't have to use this algebra, but we could. Okay, if you can figure it out from the Venn diagram, how many are in A, have at it. But to solve this, we would add number in A intersection B to both sides, so that would go away. We would also subtract the number, if we're trying to get the number in A, we would subtract the number in B from both sides. And then we'd be left with a number in A, and it'd actually be a little bit shorter than what we'd have to do here. Okay? Of course, there are other ways to rearrange this equation to solve for this number. You multiply everything by -1, then add number in A and number in B to both sides. There are all kinds of things we can do. So if you're halfway secure with the algebra, that's a good way to approach it, because we have a variety of questions here. You could be asked for any one of these 4 quantities. You have to know how to answer the question.